So we are starting here. And then they are saying before we start, scan through the data dictionary and perhaps query a couple of tables to get a feel for the database again. So I believe we did this in our last webinar. Basically, querying the entire database to get to understand the kind of data you're dealing with, how they're arranged on different tables and all that. So last time also we realized that within our database in this case is the MD water services. So I've selected it. That's why you can see it's highlighted here. And then the tables within this database were data dictionary, employee, global water access, location, visits, water quality, water sources, well pollution, and all that. This well pollution copy, you can remember we created it. It's a table we created last time while I think we were trying to do some updates. So we created it last week. So it's still there. I didn't delete it. But basically, the first part of the project, they're asking us to, query a bit of data dictionary to get a feel and probably understand the kind of data and the tables we have within this database. So if we just say select all, and then from data dictionary, we can limit it today to 10, and then we run this query. So from here, we can see that data dictionary contains information about the tables within this particular database. So we have the column of table name, which is basically the name of the table. And then we have table name, which is a column that records the names of the tables within this database. And then we have column name, which is the names of columns within each and every table. So for instance, the first table here is employee. So it means employee has a column called assigned employee ID. Again, employee table has a column called employee name, like that, and the rest. We also have description. So description basically describes each and every column within these tables. So for instance, in the employees table, we have the assigned employee ID column. And then the description here is a unique ID assigned to each employee. So basically, this column called assigned employee ID records a unique ID for each and every employee. And then the data type is basically the type of data that the assigned employee ID column stores. So in this case, it's integer, so it means it stores numbers, right? Related to basically, it highlights any other table that this particular column is related to. So in this case, assigned employee ID is related to the visits table. Okay. So in a nutshell, that is what the data dictionary table has. So you can either limit your queries or you can just select everything and then you'll see basically everything it contains. Okay. So after that, basically, you need to have a basic understanding of the kind of data you're dealing with. And I think this one we talked about last week as well. So we need to get to the first thing that we're supposed to, which is cleaning our data. So we need to bring up the employee table. So it has information on all of our workers, but note that the email addresses have not been added. We will have to send them reports and figures. So let's update it. Luckily, the emails for our departments are easy. You take the first name, and then full stop last name. First name, last name at ndogowater.gov or .gov. I'm going to guide you through this one, so code along. So basically, what they are saying here is that when we bring up our employee table, we realize that okay, this table records data for our employees. But when we bring up the table, the email column does not have emails for employees. And then they're saying here, uh, this is how the email should look like. So basically, this is like a format. So it should have the first name, and then full stop, and then last name, and then at, which is basically to indicate that it's an email, and then water.gov, which is basically the host in this case. So let's continue. So they're saying we can determine the email address for each employee by selecting the employee name column, replacing the space with a full stop, make it lowercase, stitch it all together. Okay, so let's first of all have a look at the employees table. So let's select all from employee. Let's limit it to 7. So I know you've been seeing me limiting the thing to a certain number. The reason why I'm doing this is, sometimes the table you are querying might be big. Let's say in this case, if the employees table has maybe thousands of rows. So if you just select all employees, it will retrieve everything. It will display everything. But you see, I'm just trying to understand this table. So there's no need of, trying to retrieve everything because that will actually take time. So this is one of the best practices when dealing with SQL. If you don't need to retrieve everything, then don't, just limit it. So by limiting it to 7 rows, it will take less time compared to if I had to pull up everything. And you can always confirm that down here. You see it records the time it takes to query, or when I write this particular line here, it records how long it takes for me to, for it to bring back results. So for instance here, when I queried 10 rows, that is for the data dictionary table, you can see it took 0.032 seconds. Okay. So you realize if you have to bring up the entire table, then it's going to take more than 0.032 seconds. Okay, so let's run these. So when you run these, here is the how the employees table look like. So we have the column for employee name, which has the first name, space, and then second name. For instance, the first one here is Amara Jengo. And then this is what they say. The email column is recorded as null. So in SQL, null is presumed as empty or 0. Okay. So this column is 0. So it means if we were to send some information to these employees, there's no way we can send them. If it was some formal information that's supposed to be sent through email, there's no way we are going to do that because we don't have the email addresses. You can't send a formal information that you're supposed to send via email through a phone number. Yes, we have their phone numbers here, but sometimes it will not make logical sense. So let's go back to instructions and see what is required of us. So we can determine the email address for each employee by selecting the employee name column. So you need to select the employee name column, replace this with a dot or a full stop, make it lowercase, and then stitch it together. We have to update the database again with these email addresses. So before we do, let's use select query to get the format right, then use update and set to make these changes. So basically, this is how you can do it if you want to remove that space. So you need to basically replace, select, and then in this case, we are selecting the employee name column. And then when you select the employee name column, we want to replace space with a dot. Okay, so that's why here they say they're using the replace method. This is a string function. I believe you guys have learned about string functions, numerical functions, window functions, and all that. So replace is a string function. So basically, it will replace a section of a string or whatever. So this one will, in this case, when you call replace, and then you pass the column name as the first parameter, and then whatever you want to replace will be the second parameter. So in this case, we want to replace space, and then whatever you are replacing the first parameter with, which is a full stop, will be the last parameter. So replace will take these three parameters in this case. Okay. So you need to, this one has been provided already, so you don't need to struggle. So basically you use this to replace a space. You can see this is a space with a dot. Then we use lower, which is also another string method, okay, with the result we just got. So lower, what it does is it converts everything that has been passed to it uh, into small letters, lowercase letters. So for example, in this case, you see we have lower, then replace. So basically it means after replacing everything here, after replacing space with a full stop, we want to convert that entire string, which will be the first name and then full stop last name, into lowercase. All right. So you call again the lowercase function, lower function to do that. We then use concat to add the rest of the email address. So after converting everything into lowercase here, again you call concat. Concat is also another string function that combines two or more different strings. Okay. So what this does is this first name and last name that you had converted into lower after replacing a space with a dot, again you now uh, concatenate it with this particular string, this string here, ndogo water.gov. Don't know why this thing is behaving. Yeah, so you replace it with this string. I mean you combine it, you concatenate it with this particular string, and then the new column you create a new, you have an alias. So when you use as, basically it means this particular column here, where we have done all these, we want to give it an alias name, which is called new email. Okay. So when you have as and then the name here, it means this is an alias. Okay. So all these you're supposed to do it in the employees table. All right. So basically let's do this. um, it has been done for us. Actually you can just copy and then we paste it there and then we run. So we paste that. Okay, let me remove this comment because it's, yeah, so you do that and then you run. So when you run, you can see it generates a temporary column for us just to confirm if everything is okay. So for instance, the first one here, we have amara.jengo at ndogowater.gov, and then we have Bello Azibo, like that, like that. So we have this one here. Um, let's go continue. Quick win, since you've done this before, you can go ahead and update the email column. Um, email column this time with the email addresses. Just make sure to check if it works. So we've checked that it has worked. Now we need to update the employee table, but then now we set uh, our email column, which initially was null or was empty, into whatever we have done here. So we are going to replace it with um, the new emails that we have generated for our employees. Okay, so update, and then of course we are updating the employee table. Every time you're using update, you have to also use set. Okay, so you are updating the employees table, and then you want to set the email column to be this. All right, so this one also it has been provided for us. So these first few queries have been provided, so we don't have to stress ourselves. So let's paste that one and then we run. We are having an error. We're using safe update mode, and you try to update a table. Okay, I know what is happening here. Let's comment this out, and then let's run this command up here to allow us to update. So after that, we need to run this again. Okay, now it's okay. It's okay now. So let's test out and see. Let's um, let's select employee and then we see if the emails have been updated. Yeah, correct. So now you can see the update has actually happened, and you can see now the email column is no longer null. We have emails here. So that one has worked. Of course, the commands were provided for us. So let's continue. So there's another bit we need to clean. So often when databases are created and updated or information is collected from different sources, errors creep in. For example, if you look at the phone number in the phone number column, the values are stored as strings. Um, Phone numbers should be 12 characters long, consisting of the plus sign and area code plus the digits. However, when we use the length column function, it returns 13 characters, indicating there's an extra character. So they're saying if we check the length is also another string function that will return the length of a particular string or maybe characters. Okay, characters make up the length of a string. So they're saying a phone number typically should have 12 characters, but if we run this, we're getting 13 characters. So let's run this and see if it's true. So you can see every other phone number here is 13 characters long instead of 12. Okay, so it means we have some trailing white spaces that we're supposed to get rid of. Um, so that's because there's a space at the end of the number. If you try to send an automated SMS to that number, it will fail. Yeah, so it will fail because of that trailing space that's at the end of every phone number. So here they're saying use string to write select query again. Make sure you get the string without the space, and then update the record like you just did for the emails. If you need more information about trim, you can always Google. Now, we need to trim. So basically, trim is also another string function that removes removes trailing white spaces, right? So if you have a string that is supposed to have, like in this case, the phone number is a string, it's supposed to have 12 characters, but we also have an extra space that makes it 13 characters. So we need to get rid of that space. So you can use string. I think when you talk about stream, you also have left stream and then you also have right stream. So left stream basically will remove spaces from the left side of the string, and then right will remove spaces from the right side of the string. Stream in this case will remove spaces both on the left and the right side of the string. Okay, so most of the time people will use trim because it will remove spaces if they exist both on the left and the right. So we need to update um, the column to phone number by and also in the process of updating you're actually removing the extra spaces that are there. So Let's update. So let's update. So we're updating employee. We're updating employee and okay, let me just a minute. Let me see the column. Yeah, it's called phone underscore number. So we need to write an update. So update employee.
Lord,
Yes.
there's a question in the chat that could you kindly redo the replacing email part?
Replacing email. So the thing is, with the replace email, the query has been provided for us here. The query has been provided. Okay. Okay. It's one query. You see, it's these entire statements, but they have broken it down into steps so that you can understand. Remember, the first thing we want to do is we want to replace. If we look at the employee name column here, there's this column called employee name. You can see it has both the first name and the second name of employee. Okay. So what we need to do for us to generate an email, or for us to have, for these employees to have email, let's take for example this person with the ID2. This person is called Bakari Iniko. So the name is Bakari Iniko. You can see Bakari is capital B, Iniko is capital I. So what they want us to do is, for us to have an email, we need to combine. The email should be like this. It should be Bakari, uh, Bakari.iniko at ndogomaji.gov. So this is how the email is supposed to be. So basically what should happen is we need to take the first name, combine it with the second name, and then you see there's a space between the first name and second name. So this space, we need to replace it with a full stop. Okay. And then after that, so it means you're going to have something like this. You're going to have Bakari full stop Iniko, right? This is what we are going to have at first. After having this, we need to convert everything into lowercase. So when you convert everything into lowercase, it's going to be Bakari.iniko, like this. Then after converting everything into lowercase, now we need to concatenate it such that it will be Bakari dot iniko, and then we concatenate it with at um, ndogomaji.gov, like this. So this should be the final email. Okay. So when you come to the instructions here, the first step is to the replace the space with a full stop. So you can see they are using the replace, which is a string function. String functions are functions that you use to manipulate string. Okay. String in SQL are variable characters, varchars. So within the employees table, we are interested in the employees name column. So you want to replace. Remember, we are not updating the table yet. We've just selected the employee name column that we want to replace. So we want to replace a space. You can see the second argument here, or the second parameter here, is a space, and whatever we want to replace it with, which is a full stop. Okay. So when you call the replace, we pass the first parameter, which is the column name. The second parameter is what we want to replace. The third parameter is what we are replacing it with. So we are replacing space. You can see it's quotation, but there's space. And then the second one is quotation and full stop. So it means we are replacing a space with a full stop. After replacing a space with a full stop, we are going to have this first part. We've replaced space with a full stop. So we are going to have Bakari with capital B dot Iniko with capital I. Okay. That's the first step that we're supposed to do. Then the second step is after replacing it, is you can see the command for replacing. You convert everything into lowercase. So that's why again we're using the lower, which is also another string function that you use to um, convert strings into lowercase characters or small letters. Okay, so in this case it means from here capital B and capital I are going to be converted into small b and small I. So that's this part here. Now we're going to have bakari.iniko with small b and small I. Okay, so that is after lower. Then after doing that, now we again use the concat method. So concat combines two strings. So the way concat works is if you have, let's say, the first string is Lord like this, the second string is Abiola. So you want to convert these two strings such that it makes a name like Lord Abiola. Notice that I've not included any space. So basically, it's just going to be one word. So if I call concat, if I say concat, and then I pass in Lord, comma, and then Abiola like this. If I do like this, it's going to combine Lord and Abiola so that it's one string instead of two separated strings. Okay, so that is what concat is going to do. So concat is going to take this bakari.iniko and combine it with at ndogomaji.gov so that it becomes one string. So it's going to be bakari.iniko at ndogomaji.gov. So that is the email. Okay, so now after doing all that, now we have the email. After having the email, now we need to replace it. Remember, initially the email column was null. Okay, it was null before we updated it. Now what we need to do is we need to update the table such that this column, which is email, is now going to have the emails instead of null. Okay, so again, that is what we do here. So instead of select here, remember, select, what it does, it normally gives you like a table that you can view. But that table that you're viewing, remember when you say select all and then you pass in the table name, it's going to generate a table for you, and with all the information of the table you are trying to query. That table is temporary. Okay, so select does not um, manipulate the table. It basically just generates what you are able to see, but then after that, it no longer exists. Okay, so if you want this to be permanent on the email column, we use update. Okay, so that is what we are doing here. So everything that we've done here from concat here is what we do here. So we update the employee table and then we set the email column because we want all these to be in the email column. Okay, so concat and then you set the email column to be exactly all that. That is what we have done here. So you can actually see that when you query this table, now you can see the email column as the emails of the first name. For example, in this case, you can see Bakari Iniko. Now the email is bakari.iniko at Ndogo, or it's actually Ndogo Water, at ndogowater.go. Okay, I hope now you understand what we have done there. Where were we? Oh, we were supposed to now use stream to write a select query again, make sure that we get the string without the space. So we were supposed to trim the phone number here. We've actually we've run the first query here, which is to select, and not to select, but we've run this one here for length, and we actually saw that the length of the phone numbers are 13 instead of 12. So we're supposed to update this column such that the phone numbers are 12 when you count them. plus the plus sign and also the country code. So we need to update. So update employee. So remember, I've told you guys when you're using updates, the next keyword you're going to use is set. So we want to set, we are setting the phone number, phone. So you want to set the phone number to be equal to, it's going to be equal to phone number. But now this new phone number, we want to trim it. Okay, so we are going to say trim like this. Um, Trim like this. So what is happening here? We are taking this phone number column here that we already have, which has 13 digits. Okay, and then we are trimming it. Okay, so we are removing the extra spaces. After removing the extra spaces, we reassign it to the same column. Okay, so let's run this. So it has run successfully. Now after running it successfully, now let's rerun the length command here again to now determine the length and see if an update has happened. So now you can see instead of 13, now it's 12. Now there are 12 characters long instead of 13 characters. So we have successfully done that. And actually, that marks the end of the first section, which is cleaning our data. So basically, the first section, the cleaning was not so intense. It was just a matter of, fixing the email column and also the phone number. I think those are the major things that we have done there. So let's go to the next section, which is honoring the workers. So use the employee table to count how many of our employees live in each town. Think carefully about what function we should use and how we should aggregate the data. So you get something like this. Okay, so we need to get the number of employees per town. Okay, number of employees per town. So again, here we are still using the employees table. So we have employees here. For example, if you look at this table once again, we have the employee ID, we have the name, phone number. Now we have the email, we have the address, we have province name and town name. So it means, for instance, you can see here is Ilanga. So the first employee who is this Amara Jengo comes from Ilanga, but he's not the only person who comes from Ilanga. So actually, we increase the limit here to maybe 20. Okay, I wanted to look for another Ilanga, but it's not among the 20. Maybe you can just stop limiting it. Yes, so we have this first person coming from Ilanga, but then if you scroll down, we should see another Ilanga. For example, we have Rudo Imani, who is also from Ilanga. So you want to know on each and every town, how many employees do you have? For instance, in Ilanga, how many employees do we have that actually um, come from Ilanga? Okay, so and then when we run our query, we need to have something like this. So we need to have the town name, and then we are going to create a temporary name, an alias name called num employees. Okay, so from the functions that you guys have learned about, uh, remember they've said we need to be careful on the function we are using. So how do we do this? We need to select the town name. Okay, and then when we select town name, we need to count how many employees come from that particular town. Okay, so it means if we choose on Ilanga, we are going to count how many people come from Ilanga. Okay, we're going to choose the employee. We're going to count employee names grouped by town name as Ilanga. Okay, so it means if we select Ilanga like this, we're going to move through each and every row within our table, and then on the instance as we move through the row, we're basically just counting the employee name whose town name is Ilanga. That's one method. Another method that you can do is just count the town names or count everything but group by town name. You count every row, but then you're grouping it by town name. So it means um, on first instance, it encounters Ilanga, it's going to record the first Ilanga, right? And then it goes to the second row. So if it finds another occurrence of Ilanga in the second row, it's going to record this as 2, as 3, until all the Ilangas have been counted. Okay, so let's write that query. So basically we are selecting, so we need to select town name because the town name needs to appear there. We are selecting the town name, and then now we can say count, and then we count all using the second method that I've just explained. So count all, and then you want to count it as employees. Okay, so from employee, and then we are grouping by. So when you say group by, we are grouping it. We are grouping it by town name like this. So what this is doing is it's going to select Ilanga, just the way I've explained. So it's going to select Ilanga, which is the town name, and then count all rows, okay, from the employees table, but make sure you're grouping it by town name. So if it's Ilanga, it's going to count all instances of Ilanga. Then if it's another town is what? Like Zanzibar, it's going to count all instances of Zanzibar. Okay, so let's run these. So if we run these, you can see Ilanga has only 3 employees. Then we have rural, which has 29. We have Lusaka, which has 4. Zanzibar, Dahabu, Kintapo, and the rest. Okay, so let's continue. Yes, so that's exactly what we get here. You can see Ilanga is 3, rural is 29, Lusaka, and the rest. Note how many of our workers are living in smaller communities in the rural parts of Maji Ndogo. President, okay, I'm not gonna read that. President Lydia has asked we send out an email or message congratulating the top three field surveyors. So let's use the database to get the employee IDs and use those to get the names, email, and phone numbers of the 3 field surveyors with the most location visits. Okay, so I hope you've understood that. So this is where the having the email comes
Lord,
in handy. Yes.
someone is asking if
Hmm.
we can use select distinct.
If you can use
Select distinct.
select distinct, yeah. Okay, let's actually try that and see what we get. So distinct, and then when we select distinct, this one we need to count. No. Actually, let's just count here so that you can have a. So when you use this thing, do we need to group by again? I don't think so. Count is not valid at this point. Oh, because we are using these things. Mhm. Let me test. I think it should be possible. Probably, no, probably, I just don't know the command, but I think it should be possible. Uh, okay, good. Let's see. Magnum employee. Okay, let's group by, because I'm seeing the error. Group by name. Yes, that one also works. It also works. So this one should be as num employee. Yes, so you see that one also just works. Okay, so you can use distinct. You can use this the first one that we use, which is basically to just count everything, but you group by town name. Another thing, you can select the town name, and then you also count now the employees on each and every town. So there might be different ways of doing it. Yeah, you're not restricted to just one way of doing it. Okay. I believe you can continue, right?
Yes.
Okay, good. Where were we? Okay, so you're supposed to send an email. President Lydia has asked we send out an email or message congratulating the top three field surveyors. So let's use the database to get the employee IDs and use those to get the names, email, and phone number of the three field surveyors with the most location visits. Okay. Let's first look at the number of records each employee collected. So find the correct table, figure out what function to use and how to group, order and limit the results to only see the top three employee IDs with the highest number of locations visited. You should get a table like this, but in a different order. So somebody's talking. Is somebody talking?
Continue.
Okay. So we should get a table like this, but in a different order. So this is just an example of what we should get. Okay. So we need to get the assigned employee ID and the number of visits. So we want the top three. So it means when we are recording in our table, we are going to have the employee ID, and then this should be the, for example, we want the top three. So it means there's a way in which we are going to arrange them in descending order. That is from the highest number of visits moving down. But the higher, we are supposed to limit it to only three people because we just want um, three employees. Okay. Now, we're also supposed to figure out the table we're supposed to use here. So of course, in this case, we're supposed to use the visits table because it's the table that records the number of visits. Okay. So let's again write the query. Okay, let's reduce this a little bit. So you're supposed to use the visits table. Yes, so you can see the visits table has a visit count and it also has a signed employee ID. Okay, so we need to count how many visits per ID. Basically, you're going to count the visits and then we group by we restrict it to each and every person, which is basically grouping it by ID. Okay, so so we need to select we're supposed to select assigned employee ID. So this is assigned employee ID, and then now we want to know the number of visits per ID. So basically, in this case, we're going to count. We're going to count this particular visit count. Visit count. It's visit count. I think they gave us a name. They told us on how to name the table. So it's visit count as number of visits, as visit count as number of visits. So we are doing this from visits table, but now we want to group it by employee ID. So you're going to say group by assigned employee ID. Okay. Now let's just run these randomly first before we pick the top three. So you can see here we have, for example, employee with ID 0. He has 1099. Employee with ID 1 has 3708, like that. So this one is not arranged in the order in which we want. Remember, we want the top three. Okay, we want the top three. Here, yes, they have given us. Okay, you can see the employee with ID 0 is 1099. This one is that 708. This is 2033. But we don't want these ones. Remember, you can see that 708 is greater than 1099, but then we already have this one here. So we just want the top three. So we need to we need to uh, we need to uh, um, what is it called? Oh, I'm forgetting that name. Order by, yes. So we need to order um is it yes, we need to order by this. So we are ordering by number of visits, order by number of visits, but we want the order to be in descending, that is from the highest to the lowest. Okay, so if we run these, now we get this. So the employee who has the highest number of visits has an ID of 1, which is that 708, followed by ID of that, which is that 676, followed by ID of 34, which is that 539, like that. You can see this is from the highest moving down to the lowest. Okay, but then we just want the top three. Okay, we want the top three. We don't want all these people. Okay, you can select the top three because you can see them here, 1, 30, and 34. But then you can also just limit these to 3, like this. So if you limit it to 3, it will just bring you the top 3 alone. Okay, so that's that, and then make a note of the top 3 assigned employee ID and use them to create a query that looks up the employee's information. Since you're a pro at finding stuff in a database, now you can figure this one out. You should have a column of names, email addresses, and phone numbers for our top dogs. I'll send that off to President Lady, but this survey is not problem. Okay. So now that we have the top 3 employees. Well, we basically don't know them, but we have their employee IDs and then the number of visits. Okay. So what we need to do is we need to get their names, their email addresses, and phone numbers so that uh, something can be sent to them, probably a message or something to congratulate them or whatever. Okay. Now, where do we get these? This one is we get these from the employees table. Okay. Now you remember initially when we queried the data dictionary, is that command? Okay, let's just query it, the data dictionary. So select all from data dictionary, and then we limited it to, I think it was 10 or something. You can see here that within the employees table, we have the assigned employee ID, and then look what it's related to. It's related to visits table. And then you can see in the visits table, we have the employee ID column there. So it means the way these two tables are related is via the assigned employee ID. I don't know if you guys have been taught about relationships, but these two tables are related and they're related within a specific column, which in this case is the assigned employee ID column. So it means whatever we have on the assigned employee column, assigned employee ID column of employees table is what we have on the visits table. Okay. So you can see in this case, we are getting information from visits table, but then we are getting even more information from employees table because we've gotten the employee IDs of the top 3 employees who have the highest number of visits. Now we want to know their names. It was name, email, and phone number, but that information is in the employees table. So we are again using the employee ID to get this information from another table. All right. So so we have these top 3 employees. Okay. So we want to search these particular IDs within the employees table. Okay. So we are going to select um, um, okay, let me just look what employees table have. Yes, so we want the employee name, we want the phone number, and we also want the email, right? So we want the employee name, we want the email, and then we want the phone number. Those are the 3 things that you want. So you want these ones from the employee, right? So we want this information from employee, but we want for 3 specific people. Okay, we don't want for everybody. So here we are going to use the where clause. So we are going to say where assigned employee ID. You see the column that these two tables relate on. So assigned employee ID, and then here we use in. Okay, meaning we want to retrieve information for all these particular IDs that we are going to give you. So we are assigned the employee ID in. So we have the ID of 1, we have 30, and we have 34, like that. So we need to run these. Now when we run these, you can see we get this information here. So Beloazibo is the one who is having the ID of 1. There is his email and phone number. And then the next person is what is this? Pilizola with the email and phone number. Then we also have Rudo Iman. So these are the employees whom that particular person will send them whatever it is they want to send them to. Okay. So that's that. We are done with that section for what was it called? Analyzing locations or something, I think. No, honoring workers, I think. It was honoring workers. Now we are getting into analyzing locations. Okay. So looking at the locations table, let's focus on the province name, town name, and location type to understand where the water sources are in Maji Ndogo. So create a query that counts the number of records per town. A query that counts number of records per town. For example, if we count the number of records for each town, we get that one. Okay, so number of records, I think this is in the locations table. Let's see. Let's select all from location. Yeah, I think it's location. Okay, yeah. So they want us to count number of records per town. So when you're told to count number of records, they have not specified what they want us to count. They have said number of records. So we are going to count we are going to count we are going to count um uh town names and then we are also going to group them. Okay. So you're supposed to we select. Okay, let's see what was that name. So the first column is we're going to name it as records per town, and then you also have town name. And by the way, this one seems to have been ordered. So it starts from the one with the highest records moving down. So it means we're also going to order ours. Okay. So select okay, so select count. So let's count town name as that, and then we also need the town name. So these are the two things that we want: record per town, and then we also want town name, right? So okay, from location, I believe it's location without an S. So from location, and then of course we're grouping it by town name, group by town name, and then we need to order it, okay? Because we're ordering from the town that has the highest number of records as it moves down. So order by, so we are ordering by records per town, records per town in descending, because we want it to start from the highest moving down. So we run these and we're supposed to get these. So the town with the highest, okay, so we have rural, which is 23,740. Then we have Harare like that. So this is what you should get if you run that command. Yes, so rural, which is that, Harare, and the rest. Okay. And then the next thing we're supposed to do is now we need to count the records per province. So that one was records per town. This one is records per province. And then you can see, I think this one is also ordered in descending order. So since we already have records per town, these queries are the same, okay, except that now we just change a few parameters. So for example, in this case, Instead of records town name, now we're going to have province name, and then this is records per province. This one is also province. Order by record per province. So if you run these, okay, there's an error somewhere. Let me see. It's not in group by. Oh, okay, this is province name. Province name. I hope now it should run. Yes, correct. So we have all the provinces, 1, 2, 3, 4, 5. So we have all the provinces there. We have Kilimani having the highest number of records. Then you go to Akatsi, Sokoto, blah, 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 and all that. So it's all arranged well, the way we wanted it to be arranged. Yes, so we have that. So from this table, it's pretty clear that most of the water sources in the survey are situated in small rural communities scattered across Maji Ndogo. If we count the records for each province, most of them have a similar number of sources, so every province is well represented in the survey. So we need to find a way of doing the following. Create a result set showing province name, town name, an aggregated count of records for each town. Consider naming these records per town. Ensure your data is grouped by both province name and town name. And then number 2, order your result primarily by province name. Then within each province, further sort the towns by their record count in descending order. So you should, your table should look something like this. Okay, so we need to pick each and every province, and then on each and every province we're going to pick cities within those provinces or towns, and then we are going to count records per town and then arrange them in descending order. Okay, so for example, we have a Kasi, which is the first province here. Remember, they've said here order your result primarily by province name. So okay, LM. Yes, so this is ordered by province name. So Akatsi comes first, and then within Akatsi, we have the town names. So the town with the highest number of records in Akatsi is rural, followed by Lusaka, then Harare, then Kintampo. And then we go to the next province, and then it also orders them by town name. And then we continue like that, like that. Okay. Let me think. So we need to select the province name, we need to select the town name, and then we need to count records. And then I think we're supposed to, and then we're supposed to group by province name, we're also supposed to group by town name, and then we also need to order it by province name, and then we also need to order it by, yeah, okay. All right, so let me write the query. Let's reduce these a little bit. So we need to have the province name, We need to also have town name, right? And then we need to count records for each and every town. So we need to count records for each and every town. I think I gave them a name here. Yeah, records per town. records per town. So I need to count records for each and every town as records per town, right? And then they've also said we're supposed to group by, primarily we are grouping it by province name. Okay, so let me just fill this. So we're supposed to select, so we select the province name, select the town name, and then we count records per town. So this is from locations, of course, location. So we have all that. We have the province name, we have the town name, and then it counts the records from the province name. Now we need to group. Okay, so you can say group by. So we are grouping it by, first we are grouping it by province name. So it's going to select each and every town and puts it in its yeah, it's going to select town names, and then put them in their respective respective provinces, right? So it groups by province name. Okay, so that basically means it's grouping the town names within each and every province, and then also group by town name. So it means this count here is going to be grouped per town. So it's going to count each and every town. It's going to count records for each and every town and then put it for that particular town, right? So after that grouping, now we need to do ordering. So we need to order by. So we are ordering it by province name. So it will order it alphabetically. So the province, that's why Akatsi, I think from the example, Akatsi was the first one. So it needs to be ordered by province name. So it's going to arrange those provinces alphabetically. Okay. And then we want it to also order town names. So it's going to order counts by town names. Okay. So the next ordering is now going to be these records per town. So records per town, but this one we want it to be descending because we want it to start with the town with the highest number of records as it moves down. Okay, let's test this query and see, but before that, so we have province name, town name, and then count all records as records per town. Okay, I believe this one should work. Let's do the testing. Okay, good. So you can see first it orders the provinces by alphabetically. So I believe Akatsi should come first, followed by Amanzi. These are capital, these are A's. K comes before M, I think. Yeah. And then after A, we have letter H. So Hawassa, then K, Kilimani, then Sokoto. And then if you look at these provinces, for instance, let's take a look at Akatsi. It again arranges those towns based on the number of records. So the town with the highest record. So these are the towns within Akatsi. We have rural, Lusaka, Harare, Kintampo. Yeah, 1, 2, 3, 4, only four. So within Akatsi we have four towns, and then these four towns are again arranged uh, based on number of records. So rural has the highest, followed by Lusaka, then Harare, then Kintampo. Then it goes to the second province, which is Amanzi. Amanzi again, it arranges the town names based on number of records. So rural has the highest, followed by Asmara, the Habu Amina, like that, like that. So it's going to do that for each and every province, and then within the province, town, and all that. Okay. So I believe that is understood. 62, 90, 10, 70. Yes. So these results shows us that our field surveyors did an excellent job of documenting the status of our country's water crisis. Every province and town has many documented sources. This makes me confident that, okay, that's a lot of reading. Finally, look at the number of records for each location type, each location type like these. So records per location type. So location type, we have two main location types, that is urban and rural. So we need to also write a query for that. So let's write a query for that and then get to these very many explanations later. So I believe you've understood how this query has come about. So let's write a query for location type. Okay, what do they want? Oh, number of sources per location type. Number of sources per location type. So this again, you remember the what were we calculating there? Where that other person suggested if you can use these things. So it's the same here. So here basically just select. So okay, I'm going to use count all. So count all. It was as number of sources. So we are counting all number of sources, and then also do we have location type on the location table? Okay, good. We have location type. So we are selecting, we are counting that, and then we are also selecting location type from location. And then we need to group it by location type. So group by location type. Location type. So if you run these, you should get that. So urban has 15, 9, 10, and then rural has 23, 23, 740. Yeah, okay. We can see that there are more rural sources than urban, but it's really hard to understand those numbers. Percentages are more relatable. If we use SQL as a very overpowered calculator, select that divided by that plus that times 100, you can see that 60% of all water sources in the data set are in rural. Okay, so basically what he's doing here is basically trying to get the percentages for these particular numbers here. Okay, so in short, in Maji Ndogo, most of the water sources are in rural areas. Okay, 60% of the water sources are in rural areas. And that's why you can see the figure for rural is actually kind of big. So basically in data analytics or data science, if you are to present your findings to maybe stakeholders or something of that sort, sometimes percentages are easier to interpret. You see, if you take, if you're going to meet a stakeholder and present your findings, and then you present this kind of thing, you said rural is 23,740. Yes, you have the exact figure, but sometimes you need to try and be in the shoes of the stakeholder. They are somewhat kind of busy, so they don't have time to actually get to the exact figures. But if you decipher it into percentages and you say, you know, 60% of what are those from rural, it's easier for somebody to understand that, okay, that's 60%. What about the other type? It's 40%. So 40, 60%, it's easier rather than going and telling them, you know, we have 23,740 uh, water sources in rural, and then in urban we have 15,910. Immediately you are done mentioning those figures, that person is obviously going to forget. So it's always good to, you know, work with percentages sometimes. So that's why they are encouraging us. That's why this person was actually trying to put this into percentage so that you can, you know, it's easy to communicate. I'm not going to read a lot of things there. So let's get to the second section, which is diving into the sources. Okay, so water source is a big table with lots of stories to tell. So okay, We are not getting into stories. The way I look at this table, we have access to different water source types and the number of people using each source. These are the questions that I am curious about. How many people did we survey in total? So you need to know how many people that was surveyed. How many wells, taps, and rivers are there? How many people share a particular type of water sources on average? How many people are getting water from each type of source? So I'll leave the first one to you. Try answering the rest. I'll leave the first one to you. Try answering the rest on your own too. For the second question, we want to count how many of each of the different water source types there are, and remember to sort them. So I get something like this. So we have the water source table, which records type. Okay, let's just get to see this water source table. Let's select all from. We can limit it to 12. So this is the water source table, which basically records the type of water source and then the number of people served. Okay. So for example, we have source ID. The type of water source there is tap in home. Number of people served is 956. You go to the next one, tap in home broken, like that, like that. So when we talk about number of people served, we're basically referring to how many people are using this particular uh, source as their source of water. Okay. And the funny thing is, look at tap in home and you can see number of people served here. In this case, is 956. So, okay, you might be asking yourself, how is it possible that a tap inside somebody's home is serving 956 people? But I think there's an explanation to this. Basically, when they were recording this thing, they combined very many taps in homes. If you have to record one tap in home per home, you're going to have a lot of um, uh, basically millions of records that is going to be redundant for no apparent reason. So that's why at some point, they decided to just combine these taps in homes. I think there's an explanation as we continue with the slides. Okay. So okay, so we need to count how many of each of the different water source types there are, and we have to sort them. So we need to count, for example, type of water source and then number of sources. So which of those sources stand out? It's pretty clear that although there was a drought, water is still abundant. Okay, that's a lot of stories. So basically, we need to count how many of okay. We want to count how many of each of the different water source types there are and remember to sort them. So we need to sort them in descending here, basically highest as we move to the lowest. So this is number of sources. Let me just copy this. So let's write a query that will give us the type of water source and then the number of sources. Okay. Okay, so we need to select. So we select, okay, water source. I'm trying to refer to the column names here. Yeah, so we have source ID, we have type of water source. So we need to select type of water source. And then we want to count how many we want to count number of sources for each and every type. So again, here we can use count, then all, or you can use this thing by the way, and then as number of sources. So this is from water source. So we are counting from water source, and then we need to group it. Okay, so we are grouping group by type of water source, and then they mentioned about ordering. So we also need to order by. So we are ordering by number of sources. Uh, order by number of sources. We order it in descending because we want the highest as we come down. Okay. It seems we are having an error somewhere. Table MD waters. Okay, I mentioned this is wrong table name, so it's supposed to be water source, not what here. Okay, now let's run the query. Correct. So we have these are the types of water sources. We have well, which has the highest. Then we have tapping home, tapping unbroken, shut up, and then river. Okay, so I get something like this. So here, they've only given us for two. Tapping home is 72.65. Tapping unbroken is 58.56. Is it correct? 70. Okay, yes, it's correct. So you can see wells have the highest sources, so it means they are the number of wells within Maji Ndogo are 17 created, followed by tapped in homes, followed by tap in home broken. So tap in home broken is basically a home that has a tap, but the infrastructure is dysfunctional. And then you also have shut taps, and then you also have a river. Okay. Um, okay, next up, question 3. What is the average number of people that are served by each water source? Remember to make the numbers easy to read. And then it gets these. So we need to know the number of people that are not just the number, but average number of people that are served by each water source. Okay, so we have that. So we need to calculate average. Let me see the column names. So we have type of water source, and then we have average people per source. So we need to calculate the average number of people that are served per water source. So in the water source table, you can see we have the number of people served column. So we need to find the average of the number of people per water source, right? So here we can say select. So we are selecting type water source, and then we also need the average, okay? And then you're going to name it as average people per source. So in this case, it means we need to find average. So we have a function called avg, okay? So that basically computes average. So we want average of number of people that are served per water source. So we're going to use this number of people served, but we are going to calculate average. So average of its number. Number of people served. So we want that average from water source. From water source. I think that is the day. Oh, but they is supposed to group by. So we're supposed to group by type. We're supposed to group by type of water source. So this is what we want. So run. So yeah, okay, they said we should make it readable. So this is decimal, but you can see here their numbers are actually in whole numbers. So we need to round these decimals to whole numbers. So for that, you use the round method or round function, which basically rounds it off. Now round normally takes parameters, two parameters, that is the whatever you want to round and to how many decimal places. So for example, here it's supposed to be, if I want to round it to two decimal places, I'm supposed to put a comma and then I put two. If it's to zero decimal places, it's supposed to be zero. But if you don't put, for example, in this case, just like that, it will round it to the nearest whole number by default. Okay. So if we run these, it rounds it off to whole number by default. So you can see tap in home is 644, broken is 649, and all that. So 644, 649. So the results are telling us that 644 people share a tap in home on average. Okay. So this does not make sense. So remember I told you that a few important things that apply. Okay, these ones you guys will read. I'm trying to avoid stories. But basically this section explains, I think it explains the issue of tapping home having very big numbers. Okay. Uh, so on the other hand, 2000 people share a single public tap on average. This was some of the queue times last time, and now we can see why. Okay. Now let's calculate the total number of people served by each type of water source in total. Number of people served by each type of water source in total. To make it easier to interpret, order them so the most people served by sources at top. So we are having population served, which is basically number of people served per water source. Okay, you can see how these things go chronologically, right? The first one was average people per water source. Now we want to get the actual number of people served, people served by each water source. Okay, so in this case, again, let's select. So we're selecting, of course, type of water source. We're selecting type of water source. And now we want to know the total number of people served by each water source. So in this case, if we want to know the total, meaning we need to sum people that are being served by each and every water source. So in this case, we're just going to use the sum method, okay, or the sum function. So sum, it's number of people served, and then we're going to give it an alias here as population served. Okay, so we want the number of people served from water source table, and then don't forget to group it by type of water source. Okay, so group by type of they said we should also order it, right? So order by this population served in descending. Okay, so again, if we run this, you can see that shared tab serves the most number of people at this is 1, 2, 3, 1, 2, 3, 11 million, followed by Wales, and then tabs Nome broken, and then river. Okay, so actually there are people who get water from a river. Okay, so after computing that, okay, those are stories. Make a note of the number of people surveyed in the first question we answered. Make a note of the number of people surveyed in the first question. Oh, yeah. The first question was actually asking about the how many people did we survey in total. So remember we did not answer this, but now they're bringing it up down here. So make a note of the number of people surveyed in the first question. I get a total of about 27 million citizens. Next, calculate the percentages using the total we got. So we need to know the percentage of people served per source. Okay. So remember again, guys, this is the total population. But if you present us the colder the total population, the probability of them forgetting is very fast. So you can present them, you can give them this information in a more presentable way by computing percentages. But now to compute percentages, we need to know this person is telling us that it's about 27 million. We need to get the exact figure. Okay, we need to know the exact number of people served. Now, to get the exact number of people served, I mean the exact number of people who were surveyed, we can do it in two ways. The first one, um, the first one is a table called global water access. Yes, this table called global water access. So this table has columns, and then we have the name here. So this table basically contains names of countries, and one of the countries in this table is Maji Ndogo. Okay, so if you query this table, you are able to get the total population of Maji Ndogo, okay, which is basically the total number of people that were surveyed. They were surveying Maji Ndogo, so we need the population of people who were surveyed. Another way you can do it is, you see the way we generated this column here. This column shows the number of people served per water source. You can also sum these, okay? If you sum these, you still get the same value as whatever has been recorded here. But let's get the number of people served from the global water access table. So we're going to select, actually, let's first of all select all from global water access limit 29. So this is the global water access. So I believe you're familiar with this table from your what was it called, where you guys were learning about spreadsheets. So these particular names here, if you move all the way to M, you'll be able to find Maji Ndogo. Okay, so you want to query this particular table to get the population of Maji Ndogo. Population is recorded in this column, pop n. This one is what records the population of each and every country. Okay, now these figures, another thing is they are in thousands. Okay, so it means if this one is recorded as 34,413.6, so if you want to get the exact value, you need to multiply this by 1,000 because these things have been converted into thousands. So it means 34,413.6 should actually be this should be 600. So this should be the exact figure. Okay, so it means the population for Maji Ndogo is also recorded in thousands. So we'll get it from here, and then we are going to we are going to we are going to multiply it by 1,000. So here what we can do is we can select from global water access, and then um, here we can say where name, because we are interested in the name of the country. Okay, so where name is Maji Ndogo. So if we run this, you can see we have Maji Ndogo here. So Maji Ndogo is actually a name of a country here. So you can see the population that was recorded is 27,628.1. 27,628.1. So basically it means the population of Maji Ndogo is 27,628.1 multiplied by 1,000. Okay, so if you multiply it by 1,000, we're supposed to remove 10 for the decimal. So it's supposed to be this. So this is the population of Maji Ndogo, 27,628,100. Okay. Remember that guy said it's about 27 million. So you need to find the exact figure that we're going to use to um uh, compute the percentages. Okay. So it's 27,628,100. So that's the population of number of people surveyed. So let's go back to our slides and see what's required of us. So we have the population as 27,628,100. So we need to calculate the percentage using the total that we have got. So basically, we want the percentage um, of people that are served per type of water source. Okay. Let's round that off to 0 decimals and order the results. So we are going to also round them off and also do some ordering. So we need to select type of water source, and then we want to know the percentage of the number of people served, right? So to know the percentage, we first of all need to know the sum. Okay, number of people served. So that's going to give us the sum. Okay, this sum is what we need to calculate its percentage, right? So it means it's going to be this sum divided by the population. Okay, because if you want percentage, it's going to be the number of people you've counted versus divided by total population multiplied by 100%. So it's going to be 27,628,100 like that, and then you're going to multiply it by 100. Okay, so after getting the sum, they should be as percentage people per water source, like that, and then this is of course from water source. Then we need to group by. It's just the same query, except that here we are now computing the percentages. Okay, so group by type of water source. We're grouping by type of water source. Oh, group by water source, and then order by, and then we're supposed to order by this percentage in descending. And oh, by the way, they said we need to make it readable, so it means we need to run this off so that we avoid the many decimal places. So we run this off and we have it there. So we have the shut up, which is 43%, Wells is 18, Tapinum is 17, like that, like that, like that. Okay, so let's round off to zero decimals and order. So we have that share tax is 43%, followed by uh, followed by Wales and like that. So 43% of our people are using share tabs in their communities. We don't have a review, so okay, that's a lot of stories. That's a lot of stories. Okay, so I think we are done with that particular section. We're done with that particular section. Okay, so we need to start this section, start a solution. So at some point we will have to fix or improve. Okay, fix or improve all of the infrastructure. So we should start thinking about how we can make a data-driven decision or how to do it. A simple approach is to fix the things that affect most people first. So let's write a query that ranks each type of source based on how many people in total use it. So rank should tell you we are going to need a window function to do this. So let's take a look at the problem. We'll need the following type of source, which is easy. Total people served group by type, which was done earlier, and then a rank based on the total people served group by type. So I believe you guys have learned about window function, that is rank. I think there is dense rank. Um, I've forgotten those other ones. So in this case, they are suggesting that we use rank. So basically, rank is supposed to um, uh, rank them, rank each and every row. So the way rank works is, if for example this was the first one, and we have another column, it will rank it as number one. If we have another value down here that is the same as this, both of them will be ranked one, and then number two will be skipped, so it will go to number three. But if they are in this like this, so this will be number one, number two, like that, like that. So let's look at the result from the last query. So this is what you got from the last query. It should be clear for you to see what the rank is, but you want to let SQL do it. So think about this. If someone has a tap in their home, they already have the best source available. Since we can't do anything more to improve this, we should remove tap in home from the ranking before we continue. So to use a window function on the total people subcolumn, converting it, so use a window function on the total people subcolumn, converting it into a rank. So this is how it should look like. So we have number of people served, and then rank. If you rank it by population, you have number one, number two, like that. So we should fix shared tabs first, then wells, and so on. But the next question is, which shared tab or well should be fixed first? We can use the same logic. Um, the most used sources should really be fixed first. Okay, yeah. So, okay, so first of all, we need to have this kind of ranking, which basically will rank type of water source by number of people served. So basically, and then uh, we're going to rank it by by people served, or which in this case is ranked by population. So we're going to rank it by number of people that are served. Okay, so let's write the query. This is one of the biggest projects. Takes a lot of time. So we need to select We need to select type of water source. And then we need to select number of people served. So we need to get the sum of number of people served. So this is as people served, if I'm not wrong. So people served like that. So basically what you're doing here, we want to rank it. So yeah, this is people served, and then this is rank by population. So we need to use the rank function. Rank, remember I've already said it's a window function. So the way you use rank is you just call the rank function. You just call it, it's a rank function, and then when you call the rank function, it goes with over. So rank over, and then we should have this one here as like that. So inside here is where um, you can write more queries. So for example, in this case, we want to, when we are ranking it, we are basically ordering it by the number of people that are served, right? So when we rank over, so basically what I'm talking about is this. We have the tab, and then we have the number of people that it serves. Now, how do we rank them? Remember, we want to rank them from a source that has the highest number of people served is going to be ranked as number one. Then the one that follows is going to be ranked as number two, like that, like that. So in this case, share tabs is going to be ranked number one. Then well is going to be ranked number two. And then the other one that follows is going to be ranked number three, like that, like that. So basically what we are doing here, this number of people that are being served, we are ordering them. I mean the ranks here, we are ordering them by the number of people that are actually being served. Okay. So when you call the rank function, inside here, we are going to say order, and then we are ordering by this sum here. Now in this case, remember in most of the SQL that we've been writing, when we wanted to order and we performed a calculation like sum here, we were ordering by the alias name. But in this case, we are not using the alias name. Why? Because this number of people served, it's not a column that actually exists in our real table. Our table has number of people served. So people served is not a column in our table. Now, when you're using window functions don't expect you to use columns that they don't accept temporary columns. Okay, they want the original real column. So if you want to know the number of people that are served, it's not in the people served. People served is just a column that it's a temporary column we created for purposes of query. Remember, select will accept will allow you to use temporary column names, but window functions will never allow you to use temporary column names. Okay, so that is why number of people served, we just have to pass in this calculation here, okay, to actually get the exact values instead of the alias name. And then this one, of course, it was ordered in descending. Remember up here, we ordered it by we ordered it in descending order. So we do that, and then of course this is from from water source, and then we group by type of water source. We group by type of water source, and then again order by people served. You can see outside of window functions, you can actually use the temporary columns that you created. Okay, so order by that in descending. Yes, so if you run this, you can see that now shared tabs is ranked as number one, followed by wells, then tap in home, blockchain, and river. Okay, so we've done that. Now Here, the next thing you're supposed to do here is, for example, if you want to fix share tabs, okay, which share tab or well should be fixed first? You can use the same logic. The most used sources should really be fixed first. So, for example, what basically this is saying is, let's say, for example, we want to fix, okay, we know that share tabs is having most number of people. But now we have shared tabs in different locations. You can have shared tab A, tab B, tab C. So these three tabs, they serve different number of people. Let's say tab A serves 500 people, tab B serves 200, tab C serves 50. If you have to fix these tabs, if they are broken, fixing tab C, which serves 50 people, will not be effective. So if you want to fix them, you start with the tab that serves the highest number of people, right? That way, you would have helped a lot of people. So you start with the one that serves highest number of people. You go to the one that serves, for example, in this case, the highest number is 500. After fixing it, you go to the one that serves 200. Then you finally finish with the one that serves 50 people. So from this one here, uh, what they want us to do is to create a query to do this and keep these requirements in mind. The sources within each type should be assigned a rank. Limit the results to only improvable sources. Think about how to partition, filter, and order the result sets. Then order the results to see the top of the lists. So this is what you got using rank. So basically you have type of water source, river, foundry, like that, and then priority rank. By using rank, teams doing the repair can use the value of rank to measure how many they have fixed. But what would be the benefit of using dense rank? Maybe it's easier to explain to engineers this way, or the priority feels a bit more natural. So basically, what is saying here is this one here has generated this using rank function, but actually it will be easier to generate this using dense rank. Okay, it will be easier to use dense rank compared to if you have to use rank. So there are things you're supposed to fulfill here while writing this query that will generate or give us the type of water source, the number of people it serves, and the priority. Okay. So priority in this case, just the way I've explained, if you want to fix shared tabs, you need to start by fixing the one that serves the highest number of people. So basically, now the query that we're going to write will involve all the types of water sources. So we are going to start with, for example, rivers. Which river are we supposed to fix first? And then we go to shared tabs. Which shared tab are we supposed to fix first? Then you go to the other water sources like that, like that. Okay. Now to do this, we are going to use a dense rank instead of rank because I believe rank will complicate this thing a lot. So let's write a query to do that. So okay, let me just so we need source ID, type of water source, number of people served, and then this is going to be priority rank. Source ID, type of water source, number of people served. So we need to select source ID, then type of water source, and also number of people served, number of people served, and then after selecting number of people served, now we need to calculate, we need to generate that priority rank column. Okay, Now to generate that, instead of using rank, we're going to use dense rank. So dense rank, and then this one is also over. Then so the syntax for rank and dense rank is the same. The difference comes in whatever you'll be writing inside it here. Okay. So for that other one, we ordered. Now this one, what we are going to do is this. Remember, we want to partition it by each and every type of water source. Okay, so if it's river, we want to identify, if it's a shared tap, we want to identify which one is going to be fixed first. Okay, so we are going to give them priority. The one that serves the most number of people is going to be fixed first, is going to be given priority 1, and then the one that follows is going to be given priority 2, like that, like that, like that. So what are we going to do? First, let's partition it by type of water source. Okay, so we say partition by type of water source. Okay, so after partitioning it by type of water source, basically it means it's going to categorize them based on water source. And then after that, we are going to order. Okay, now how are we going to order it? We're going to order it by the number of people that each and every water source has. So basically what's happening here is you partition it by water source. So for example, share tap is going to be categorized as share taps. River is going to be categorized as river. Then on each and every partition, now you order it by the number of people served. So for example, if it's share taps, we want to know out of these share taps, because we have different locations, we want to order them by the number of people that each and every one of them serves. So we're going to order by number of people served. We're going to order it by number of people served. Okay. And then this is from water source, and then after that, now let's order everything um, priority rank. By priority rank. Oh, I think there's an error. Unknown column number of people. Okay, this is the number of people. This should be underscore. Okay, correct, 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 correct. This is very big. So, okay, this is correct. So we have the first, for example, type of water source here. So we have well. Yeah, good. So what is happening here is this thing gives us uh, um, the wells. So it starts with wells, okay? Wells that are supposed to be fixed. So it has the IDs for wells that are categorized as priority number 1, and also the number of people they serve. So take note of the number of people that are served. These wells served at least 160 people. So we give them priority 1. So it means they are the ones that are going to be fixed first. Okay. So this is priority 1 for wells. If we come here, this is priority 1 for tapping homes. Take note that priority 1 for wells is 160. Priority 1 for tapping homes is 300. And then for river is 400. Okay, I'm going to scroll. For shared tab is 200, like that, like that. So, and then after priority 1, it goes now to priority number 2. You can see tap in home is 302. Tap in home 302. Wells is 303. 160. This is yeah, rank number 2. No. This is supposed to be less, I think. It's supposed to be less, if I'm not wrong. Um, okay, maybe there's a problem in my query up here. Partition by type of water source, then order by number of people served. Okay, yeah, order by number of people. This should be descending. This should be descending. So let's run. Okay, good. So wells, number of people served, this is 398. So the first well that is supposed to be fixed is this one with this ID, and then the number of people served, like that. So it will rank all these numbers that are of the same priority together. So this is 398 for wells. Tapinome is 998. So you can see for those two, 398, 998. So that is rank 1. So it means they have the highest number of people that are served. So it means they're supposed to be fixed first. Let's go to rank 2, the one that has been given rank 2. That one was well and tapping home. So let's move to rank 2 for well. So that was 398. You can see this is 396. So the numbers reduced. So we started with the ones where um, we started with fixing the wells that serve highest number of people, and then we go to one that serves few. So this is 396. If you go to rank 3 for wells, this is 394, like that, like that, like that. So it will start for people who will be fixing the taps, they will start with taps that serves the highest number of people as they move down. Okay, so I hope that is understood. So by using dense rank and all that, so try the different ranking functions in queries. Imagine yourself in an engineer as boots and try to interpret the uh, all that. Okay, these are stories that people can read later. Analyzing queues. Okay, so this is really big, and last table we'll look at this time. The analysis is going to be a bit tough, but the result will be worth it. So the visits table documented all of the visits our field surveyors made to each location. For most sources, one visit was enough, but if there were queues, they visited the location. Okay, so these are some of the things I think are worth looking at. How long did the survey take? So we need to know how long the survey took. What is the average total queue time for water? So we need to know average total queue time for water, average queue time on different days, average queue time on different days. How can we communicate this, find information efficiently? Try to answer some of these questions. Think of the data you will need to answer each question and how to transform that data into the right form to answer the question. So there's a hint there. I have to read up a bit on control flow, the time and window functions to do this. So you probably will have to as well. Look at the visits. Okay, let's get to the question. So question 1, calculate how long the survey took. We need to get the first and last dates which functions can find the largest or smallest value and subtract them. Remember, with the date-time data, we can't just subtract the values. We have to use a function to get the difference in days, to get the difference in days. Okay, so when I do it, I get that one 924 days, which are about 2.5 years. So we need to calculate how long the how long this survey took. We need to calculate how long this survey took. Okay, which table has that information? Is it visits table? What? Let's see what visits table has. So visits table, correct. So we have time of record. We have time of record. So we want to know how long the survey took. Meaning, what we're going to do is this. We're going to find within this time of records column, we want to find the maximum dates, and then we subtract the minimum dates. Okay, so that will give us um, the the difference. So maximum date basically means the time this survey was finished. Minimum is the time it was started. Why are we using time of record? Because when the survey started, these people are recording the dates in which they were doing their work. Okay, so the least date or the minimum date will be the date upon which the first record was taken, and then the maximum date is going to be the date in which the last record was taken. Right now, I believe we've also learned about data in functions. Okay, so I think here we're going to use maximum, max, min, which are basically numerical functions to get the uh, maximum time of record. Min is going to give us the minimum time of record. And then because this record records the date and time, we're going to use the date diff function, which gives us the difference between dates. Okay, so we can select. So we are set. Okay, what? Let's see what they want us to have. Oh, okay. So let's select. So you want the maximum for time of record, maximum for time of record, and then you also want minimum, minimum time of record like this. Okay. So we are going to call the diff on these. So what the diff does is it takes the first parameter, which is the maximum time of record, and also it subtracts it. It will take the second parameter and subtract from the first parameter. Okay, so you select that one. Maybe we can give it an alias, so you can say duration, or I don't know, maybe you can call it duration from visits. Yeah, we get 924. Yes, so 924, that is very correct. So just imagine all the, okay, that is that. These other stories we will read by eye. Question 2, let's see how long people have to queue on average in Maji Ndogo. Keep in mind that many sources like tabs in home have no queues. These are just recorded as 0 in the time in queue column. So when you calculate averages, we need to exclude those rows. Try using null if to do this. So you want to calculate average time in queue, but because people who have tap in homes don't queue. If you have a tap in your home, you basically just go and take water. So we need to exclude that. And they have specified here that we use null if. So what will null if do? So null if basically it will record, it will check columns that are recorded as 0, and then it will make them, turn them into null. So that when you'll be calculating average, average basically will ignore the columns that are recorded as null, because null is not a numerical value. So it will not compute the average. Okay. So you should get queue time of 123 minutes. Okay, so let's compute that. So they want average, how long people have to queue on average. Okay, so they want average time in queue. Average time in queue. So, okay, and we have to use null if. So we need to select time. Where's the visits table? Let's see if it has queue time or something like that. Yeah, we have time in queue. So we want to calculate average of time in queue. So basically this will be average. We want to calculate average of time in queue. This is from visit. So you want to calculate average of time in queue, but when we are calculating this average, first of all, we are going to check that column for time in queue, and we are going to check if it has 0 values, and then we are going to turn those zeros that have been recorded where we have tap in homes, we're going to turn them into null. So it means this particular column, we're going to say null if, so null if this column comma has zeros. Okay, so what this does is it's going to check every row of the time in queue column. If it has 0, it's going to be replaced with null. Okay, so let's run these. So you get 123 point something something. So maybe we need to round this off so that we get 100 and yeah, so 123. Maybe we should have named these as average queue time. Yeah, average queue time. So we get 123, just like they have mentioned there. So 123 minutes. Then question 3. So let's look at the queue times aggregated across different days of the week. Queue time across different days of the week. Day gives you the day of the month. If you want to aggregate data for each day of the week, we need to use another datetime function, day name, and then the column. As the name suggests, it returns the day from a timestamp as a string. Use that on the time of record column. Using that on the time of record column will result in a column with the day name as Monday, Tuesday, blah, 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 and all that. So to do this, we need to calculate the average queue time grouped by day of the week. Remember to revise the blah, blah, blah. Okay. So we need to calculate average queue time for each and every day of the week. Okay. So average queue time for each and every day of the week. So that means for each and every day of the week. So we are going to use time of record. So time of record, I think it records day, time, and all that. Okay. So when we have the dates given for us like that, for example, you are given 2025, maybe 9th November and all that, and then you've been given time. So when you use the day name function, day name is able to actually extract the exact day if you pass in that particular date there. Okay. So it will be able to calculate, check the calendar and see the year, month, and then it will be able to retrieve the exact day. Okay. So what we are going to do here is we're going to select. So, okay, what were the column names? Day of week. And then this is average queue time. So we're going to name this as day of week. So let's select, so we want day name. We want day name for time of record, okay? For time of record, and then you're going to name it as we're going to name it as day of week, right? And then we want the average. We want the average. So I think average, basically it's going to be the same formula that we've used up here. So average and then null if the time in queue, like that, like that, from visits. And then we have said we need to group it by day of week, group by day of week. So if we run this, okay, maybe we need to run this off round. Yeah. So you can see Fridays are the highest average. So it means mostly people fetch water on Fridays, then look at Saturdays also. So it means basically in Maji Ndogo, people mostly fetch water from Friday, Saturday, and Monday. Mondays people are fetching water so that they can prepare, go to work. And then on Saturday, since it's a weekend, people don't have anything they do. They fetch water. Sunday is the least because probably we can assume people from Maji Ndogo are religious. On Sundays, maybe probably a lot of people go to church or something like that. Okay, so we have 120. Okay, I think we got it correct. Saturday have much longer queue times compared to the other days. Okay, question 4. Now, now for question 4, we can also look at what time during the day people collect what and try to order the results in a meaningful way. So you get something like that. So we need to write a query um, that will give us the average queue time per hour of day. Average queue time per hour of day. I don't know about you, but the hour number is difficult to interpret. A format like 0600 will be easier to read. So let's use that. So I'll help you with this one. To format time into a specific display format, we can use time format and then time and then the format. It takes a time data field and converts it into format like this. Okay, so they're using the time format. Okay, so you can see here, time format is a method that basically converts whichever time record you've given into the format that you want it to be in. So for example, in this case, this guy wants the format to be in hours and minutes. Okay, so he passes the time of record time. So basically it means this thing will go to the time of records column. And then since our time is recorded by date and time, when you call the time function, it just picks the time. Okay. So if it's recorded as 2025 11 November 10:00 a.m., it will omit the date and it will just pick the time, which is 10:00 a.m. Now, after picking that time format now will basically put it into the format that you specified in this case. In this case, this person has specified hour and minute. You can also specify it as 24-hour system or whichever. Okay. So try it and now look at the format. So if you try it, this is the format you should get. So we have, for example, 0600 and then average queue time like that. Um, you can see that morning and evenings are the busiest. It looks like people collect water before and after work. Okay, so this has been given here. So select time format. So time and then time of record, and then this is the format you want the time to be in. And then we name that column as hour of day. And then you also select the day name. Okay, and then user case. User case. Okay, I think before this, you're supposed to actually just do this to uh, know the time and also the hour of day. We need to do this to calculate the average queue time per hour of day. Okay, so I think we can do that before we get into the other query. So we need to, they told us to use time format, right? So let's see. So for that means we need to select time format and then we pass time, time of record, and then also we specify the record, and then we calculate the average. Okay. So that means we'll select, so time format and then time of record. So because we use time format, we need to specify the format. So we want it to be percentage hour and minute. And then this is hour of day as hour of day. And then we need to calculate also average queue time. So average is still the same. Timing queue. Is it timing queue? Timing queue. Average. Actually, let's round this off so that we don't have to come back again and so that one, put that one from visits, and then we have to group by hour of day. Yes. So 149. Let me just confirm. I think I saw 6. Okay. 6 is 149, 7 and 8 is 149. So at 6 a.m. 149. So it means people are busy at in the morning. 6, 7 is also 149. Where is 8? Where is 8? Where is 8? It's 9. So at 9, probably people are already at work. And then also in the evening. So you can see this is 7 p.m. in the evening. This is also 6 p.m. in the evening. Why am I not seeing 8? Oh, here is 8. Okay. So in the morning and in the evening hours is when queue time is highest, because probably it means people collect water before they go to work and also when they come from work. Okay. Okay. So good, 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 good. Morning and evening are busiest. Yeah, we can see that. Now, to filter a row, we use where, but using case in select can filter columns. We can use a case function for each day to separate the queue time column into a column for each day. Let's begin by only focusing on Sunday. So when a row's day name, time of record is Sunday, we make that value equal to time in queue and null for any days. If we run this query, we'll see what I mean. So we have a case here. So what it does is where day name is Sunday, when the day name is Sunday, then time in queue. So it will record time in queue. If the time in queue is not there, then it will record it as null. Okay. Okay. Let's write this and see. They said we should test it and see. So yeah, for example, you can see where we have values. This is Sunday, you can see the name. So it records Sunday. If there is no value, it will record it as null. So that is this line here. When day name is equals to Sunday, then time in queue. So it means if day name is Sunday, then record time in queue. Else, if there's no figure there, then just record it as null from visits. So time in queue is not equal to 0. Okay. So when the day name is Sunday, there are queue time values and all other rows are null. So now if we aggregate that column, we'll use all of the values that are not null. By adding average around the case function, we calculate the average, but since all of the other days values are 0, we get an average for Sunday only rounded to 0 decimal. This is the form of the query. So I believe these ones you guys can read and understand. This one you can actually use it to generate a pivot table. So this is basically showing the power of case. And then they've also visualized it. I think visualization you will do it next. So basically, from all that we have done today, these are the insights that you can draw. These are some of the most important insights that you can get from whatever we have done. So from the queries we've written, you've seen that most water sources are rural. I believe you can remember where we counted that. We said we got 60%, and then 43% of people are using shared taps. 2,000 people can share one tap. 31% of the population has water infrastructure in their home, but within that group, 45 face um, and functional systems, that is those taps in home broken, and many other insights. And then from those insights, you can actually start a plan on what to fix, where, and how. Okay. So the queries you've written should be able to help you, answer the MCQs that I believe you have ahead. Some of the questions will come directly from these queries that we've written. So, for example, um, you can be asked maybe based on the query that you've written on the queues per day. Maybe there's a question that asks which day has the highest number of queues and such kind of things. So I believe, okay, this is the longest project that you will do here. This document is actually 40 pages, but at least the last parts, you don't really need to write a lot of queries. It's just explanations, and most of the queries have been given to you.